Hello guys, welcome to another video. Today we'll work on forces, topic 2.2. So let's jump straight into the exercises and see the solutions. Question number 1. It says that we have two forces of magnitude 12 newtons and 24 newtons act at the same point. Which force cannot be the resultant of these forces? So what you can do here is to see the situation of the forces acting and give you the maximum range and the minimum range of the resultant force. So of course this situation is, let's say, the 12 Newton force, it acts to the right, and the 24 Newton force, it acts to the right as well. So the resultant here, it will be 36 newtons. And now the minimum force that you can take is when you have the situation that the two forces, they are acting in the opposite directions. So if you do the addition in this situation, you will have 12 newtons. Now whatever other combination you have, it's between these two numbers. So we see here that we have an answer of 10 newtons, so this cannot be a resultant force, cannot be smaller than 12. In the next one, we have a block of weight W slides down a ramp at constant velocity, so this is important. A friction force F acts between the bottom of the block and the surface of the ramp. A normal force reaction M acts between the ramp and the block. What is the free body diagram for the forces that act on the block? Of course, here with constant velocity, you have zero net forces. So you have translational equilibrium. So what you need to do here, you need to resolve all these situations and see which one it gives you equal forces in both axes, Y and X. So it's pretty clear from here, cannot be B, cannot be A either. Now maybe you will be a little bit confused from C, but still, if you resolve the forces here, so you have the M and you have also the F in the same direction. So if you add those two, they're way bigger than W, so it cannot be C either. So the only correct answer here is D. If you resolve the forces here, you will see that they are add up and they give you an equal magnitude as the W downward. The number 3, it says that a waiter carrying a tray is accelerating to the right. Accelerating to the right. This is very important, as shown in the image. What is the free body diagram of the forces acting on the tray? So if it says that it's accelerating to the right, in the right direction, we need to have a force in this direction. We cannot have any forces to the y-axis. So from here, pretty clear again, cannot be A, cannot be B. Now what is happening between C or D? Well, here you need to resolve again this situation. So you have the upwards force here and the horizontal force here. And you see that the downward force with the upward force here, it's not equal. So it cannot be C. On the D though, you have the upwards force here and the horizontal force here. And you see that these look very, very similar. So the correct answer here is D. The number 4, it says that a book is at rest on a table. What is the pair of action-reaction forces for this situation according to Newton's third law? So when we have action and reaction forces, remember that the action and reaction forces, they are acting on different bodies. So whatever the law says, body A to body B, then body B to body A. So you look for this situation, A to B and B to A. So what you need to do is just to check here the words. So in the first situation you have book and table, and then you have book and earth. So it's not A, B, B, A. The second says table, earth, book, table. Again, cannot be. The third one, you have earth, book, book, earth. So this is your situation, A, B, B, A. And the last one is earth, book, table, book. Cannot be as well. So your only choice here, it is C. Remember, Newton's third law, we have the pair of the objects, A, B, and B, A. Number 6, it says a uniform ladder resting in equilibrium again on rough ground leans against a smooth wall. Which diagram correctly shows the forces acting on the ladder? Again, the same thing. We need to see all the directions of the forces and all the forces they need to cancel out. So for example here, A, you have two forces to the left. You have nothing to the right. Cannot be A. Here, number C, you have 5 forces. You need equal forces in every direction. Here, in number D, again, 2 forces to the left. So it doesn't work. Here in number B, though, you have 1 to the left that is equal with 1 to the right. 1 upwards that is equal with 1 downwards. So the correct answer here, of course, is B. Number 7. It says that a box is accelerated to the right across rough ground by a horizontal force Fa. The force of friction is Ff, the weight of the box is Fg, and the normal reaction is Fn, which is the free body diagram for this situation. Again, we have acceleration to the right. So in the vertical axis, we need to have 0 resultant forces. So it cannot be B, cannot be A, because you see one force up, one force down here and here. Now we want also for the object to accelerate. So we cannot have equal forces in the horizontal axis. So it cannot be C, of course. The only correct choice is D. Upwards and downwards force equal, no motion to the y-axis. The Ff is smaller than Fa, so the resultant force it will be to the right direction, F net, and this will make the object to accelerate to the right. Now number 8. So this problem it's one that you usually see, and it's a little bit not hard, but sometimes we get confused. We have a weight W that is tied to a trolley of mass M by a light string passing over a frictionless pulley. The trolley has an acceleration A on a frictionless table. The acceleration due to gravity is G. What is the W? So what we need to do here is to find this weight W of this mass, let's call it small m. So you know that the trolley, it accelerates with acceleration A to the right. So we have to follow some specific steps here. First of all, we are going to work with Newton's second law, that the net forces, we see this as a system, not as individual objects. The net forces that are acting on the system is equal with the total mass of the system, let's call it m total, times the acceleration of the system. And this is your acceleration of the system, the acceleration of the trolley A to the right. So now from here, before we start solving this one, seeing what are the forces and stuff, we need to create here the free body diagrams for the object. So let's go and try to draw the forces. So of course, for the trolley, you have the downwards force of the W of the weight of the trolley, and you have also the normal to reaction N, because that is in contact with the table. But of course, these are equal and opposite in direction, so they cancel out, so we don't really care about those. Now, what other forces? We have the W here of this mass, M, that we're trying to solve, and also we have here the tension of the string, let's call it T, that is attached with a W, with a mass M, and also the tension of the string here that is attached with the trolley. And these are all the forces that are acting on the object. Now my next step, in order to not miss anything, is to set the positive and negative direction. So we have motion to the right, to the horizontal, so we need to set up the positive and negative direction here. Of course, the object moves to the right, so I'm going to choose the positive to the right, negative to the left. And you have also downwards motion, vertical motion here. Again, the same thing, the object moves downwards, so I choose positive down, negative up. And now from here, I'm going to start solving my problem. So I'm going to see the net forces. What are they? Who are they? We have the W. We have the tension force in the negative direction. You have also this tension force in the positive direction. That is equal with the total mass of the system times the acceleration. And now from here you can see that the tensional forces, they cancel out because they are equal in size. Here it should say that the string, it's not elastic, but anyway, we can just assume that. So the tensional forces are same. So now from here you end up having the weight of the object that is equal with the individual masses of the trolley and the weight. So it's the mass of the trolley plus the mass of the weight times the acceleration. And now from here you see that you don't have this mass, but what you're trying to do is to solve for W, so somehow you need to relate this mass with W. So you know, of course, that the weight of the object is equal with the mass of the object times the gravitational acceleration. So you need to solve here for the mass, is the weight over the gravitational acceleration, and I'm going to use this equation here in my first one. So what I have here is that the W is equal with the mass plus the W over G multiplied by the acceleration. And now from here, you just have to solve this equation. So I'm going to do it fast. From here, you need to rearrange, bring the W to the other side. So you have W minus W over G times A is equal with M times A. And from here, you need to take the common multiplier, the W. So in order to do that, I'm going to multiply here and divide also by G. So what I have W times G minus A, and all of it is divided by G, and this is equal with mass times acceleration. And from here I will just rearrange in order to solve only for W. So I have the mass times the acceleration times the gravitational acceleration divided by gravitational acceleration minus the acceleration. So here you can compare it with your choices, and of course you see that your choice is A. Now this question, of course, it takes a little bit more than 1 minute and 30 seconds, but still, if you are familiar with the way to solve these problems, you can do it quite fast. Let's move to the next one, number 9. It says that we have a parachutist of total mass 70 kilograms is falling vertically through the air at constant speed of 80 meters per second. What is the total upward force acting on the parachutist? So here, of course, you have to create a free body diagram to visualize the situation. You have the W, the weight of the parachutist, and also the air resistance force. Let's call it R. And this is the force we're looking for, the upward force. From here, we see constant speed, so we know that R and W, they should be the same, and W, of course, is the mass times the gravitational acceleration. So 70 kilograms times 10 meters per second squared, it will give you 700 newtons. And also this must be the upward force as well. Of course, correct answer is D. And now the last one, we have a diagram that shows the forces acting on a block resting on an inclined plane. The angle theta is adjusted until the block is just at the point of sliding. R is the normal reaction, W the weight, and F the maximum frictional force. What is the maximum coefficient of static friction between the block and the plane? So here we need to work with, of course, the friction formula, that it is the coefficient of friction times the normal to the surface force. We talk about the maximum coefficient of static friction, so just before sliding, so we have the maximum frictional force. So from here, I need to solve this one for the coefficient. So it's the frictional force divided by the R. But now you have nothing for frictional force or the normal to the surface force. But what you have here, you have W. And also, you know that the object is resting. So what you need to do is to resolve this W in the two different components. So here it's going to be the W, let's call it Y, and here it's going to be the W X. If this object is resting, that means that they need to be equal with the other forces. Also, you can see that the angle theta, using geometry here, you see that it's here. So here is your angle theta. So first of all, the frictional force, F. What is it? Is the W times the sine of theta. And this is actually the component of the weight in the x-axis that is equal with a frictional force. From the other hand, you have the r, that is the adjacent component of w, so is the cosine theta, this is the wy. So if you replace these equations here, you have w sine theta divided by w cosine theta. The w's are cancelled out, sine over cosine theta, it gives you tangent theta. And of course, your answer here is C. And that's all for today, guys. Not super difficult topic of forces, but still you need a lot of practice in order to be able to solve it easily. So study hard and good luck.